Hello everyone, welcome back to Cis Theta Learning, where we continue with the system design course. So, in the last video, we saw vertical scaling versus the horizontal scaling. I hope you remember in vertical scaling, what did we do? We added more CPU and RAM, and in horizontal scaling, we added more machines. So, we spoke about a problem, right, previously. So, users are connected to the web server directly. Users will be unable to access the website if the web server is offline. In another scenario, if many users across the web server simultaneously, if many users access the web server simultaneously and it reaches the web server's load limit, right, users generally experience slower response or fail to connect to the server. So this is where a load balancer is needed. So what is a load balancer? A load balancer is like maybe you say a traffic police of your system. It sits in front of your server. If you see, I have a load balancer here. I have drawn this load balancer. So this load balancer is like a traffic police of your system. It sits in front of your servers and directs incoming requests to the appropriate backend server. So let's understand this diagram. Now, as we see this figure, users connect to the public IP, right? Where is this public IP? This is the public IP. Okay. So users connect to the public IP of the load balancer directly. With this setup, web servers are unreachable directly by clients anymore. So this web server, right? These are unreachable by the clients, that is user directly. So for better security, private IPs are used for communication between the servers. So if you see private IP I have given here. So a private IP is an IP address reachable only between the servers in the same network. That is, in the same network, we can reach it. However, it is unreachable over the internet. So the load balancer, this load balancer, right? The load balancer communicates with the web servers. That is, yeah, this I've given you the mark, right? So this load balancer communicates with the web servers through what? Through the private IPs. So in this figure, after a load balancer and a second web server are added, right, we successfully solved no failover issue and improved the availability of web tier. So see, if this server 1 goes offline, all the traffic will be routed to this server 2. This prevents the website from going offline. We'll also add a new healthy web server to the server pool to balance the load. So if the website traffic grows rapidly, that is many users are just sending a request, and if these two servers, what we have shown, right, server 1, server 2, if these two servers are not enough to handle traffic, the load balancer can handle this load balancer, right, can handle this problem gracefully. You only need to add more servers to the web server pool and the load balancer automatically starts to send requests. So yeah, so why do we need the load balancer, right? One is distributing load, one is fault tolerance. What is fault tolerance? That is, if one server goes down, the traffic is routed to the other. So here we saw, next is we saw this scalability, and it also helps with maintenance. You can take down one server without downtime, right? So how does the web server how does this load balancer work? So a user request first hits the load balancer, right? Whatever cool startup.com, whatever one user request, after it gets the IP, it will hit the load balancer. Which then decides which backend server should I handle this? Which backend server should handle this request, whether server 1 or server 2. So the common strategies that are used are maybe round robin. That is like passing a ball in a circle. Request one request will go to server 1. Request 2 will go to server 2, request 3 will go to server 1, and so on. Then least connections. So, okay, let's see. Okay, first strategy was round robin, right? Second is least connections. So what is this? Least connections. Send the request to the server with fewest active connections. Next is, third one is IP hashing. Okay, IP hashing. What is IP hashing? Request from the same IP always goes to the same server. Good for session stickiness, that's all. Then weighted round robin. If server A is stronger than server B, it gives more requests. So next is you have this types of load balancers also. Maybe, okay, this video will become too long if I go with types of load balancer. Let's cover the types of load balancers in the next video. I hope you got an idea of load balancer in this explanation. If you have any questions or if you want more detailed explanation, please let me know in the comment section. And if you like this video, please do share and subscribe. Thank you. We'll meet in the next video where we'll see types of load balances. Thank you.